Okay, so hi there. My name is Eran, and here with me today is Sagi, who is team leader of the financial infrastructure development team. We're both from Payoneer, and we're going to talk a bit today about how we embrace some modernized methods and some non-SQL technologies into the fintech solution domain, and of course, how we survive to talk about it. But let's start off with a short story. So yeah, first of all, although I am a big fan, I'm not gonna promote Redis in this MongoDB convention. I do think it's a great solution, but this is not the purpose here. So what's the problem? Just put it in Redis. So this phrase is actually something funny that we used a lot in one of my previous companies, and I want to tell you about it. So in one of my previous companies, there was this business development manager. He is a great person, by the way. I really like him. But he doesn't have any technology background. I still like him, nevertheless. And what this guy did, he was very good at his job. He used to hear us talk a bit or a lot about Redis, about using Redis for different solutions, for different problems. And I think he heard it a lot. So he came to the understanding that Redis might solve many of the problems the business or the requirements the business requires here. And so this guy took an habit of coming to us with any new feature or request he wanted, and he would say, okay, this customer requires this and that, or I want us to develop this feature, and tell me, can you use the Redis for it? Or, even what's the problem? Why just not use the Redis for it? And this whole notion of coming to us with, the problem and the Redis solution pretty much caught up with the rest of the companies, and you can hear other people like product and project and business come to R&D and say, wow, we have a problem, we want to solve something, and can you use the Redis for it? And why not use the Redis? And of course, as you probably know, engineers likes nothing more than someone come up to us and say, wow, here's the problem, can you use this solution? And especially when it's not the right one. And of course, I'm saying it in sarcasm, but we did took it in a great spirit and a good spirit, and we started making fun of it. And at first it was like, any new problems in the R&D, someone would say, what's the problem? Just put it in Redis. So it could be, for example, our service is down. Okay, what's the problem? Just put it in Redis. And, we have a memory leak. What's the problem? Just put it in Redis. Or some UI mistake. What's the problem? Just put it in Redis. And of course, it spread it to and extended to more than just development or production issues. Like, someone would say, wow, I have I have a parking problem in my neighborhood. So someone else would come and say, okay, so what's the problem? Just put your car in the Redis. Or someone would say, wow, my husband is not helping around the house. And we will tell her, okay, what's the problem? Just put it in the Redis. So I'm not sure how much you get from this, but we did make a lot of fun around this. And actually, I took it with me to Payoneer as well. And some people in Payoneer also heard about it and make fun of it like I do. But in the end, when I got to think about it, this guy, the guy who started the whole conversation, who said it, he wasn't really wrong, he wasn't far away from the truth, because sometimes as engineers, we do tend to reuse the same solution for new problems. We tend to do it, and we do it a lot, and we don't even feel it. We tend to change a bit the way we look at the problem and try to force a solution we know and familiar with about it. So taking up to the next slide, and sorry, because I think Uri Levin, the founder of Waze, also said it. He said, fall in love with the problem, not the solution. But I found this slide by Ash, and it was green, and I had to give something back after I put Redis in the first slide, and this is a MongoDB, so I put the green slide in it. But returning back to the love the problem, not the solution, I think it's a very, very good quote. I really like it. You can take it and interpret it in so many ways. In this presentation, I'm going to talk about how new challenge can be a great trigger for new initiatives. If you look at the problem and you really examine it, you can do things a bit differently and do great initiatives to change things a bit. And it's a great opportunity for your evolution, both your system and personal. But before I talk about how some of the new issues or how the new problems we saw trigger us with great innovation, I would like to share a bit about Payoneer, okay? So if you're not familiar with us, we've been around for some time now. We are a fintech unicorn. We're a global company, and we serve many countries. Of course, I highlighted here the main thing about growth, and the 50% year-to-year growth of 2020 is not something special for 2020, although 2020 was a special year, obviously, but the growth of Payoneer is something that comes along for several years now, and 50% year-to-year growth is not something that is very, very unique for 2020. And the reason I'm saying it because a company that grows that fast in so many years is it brings a big challenge, or a great challenge for R&D to catch up with the scale, and this is part of the problems we're going to talk about in the or the triggers for new solutions that we will talk about in the next slides. So just to sum up things about Payoneer, so we serve some major brands, as you can see from this list, some great companies, and it also adds up to the responsibility we have to have a good product that these companies can rely upon. And over the years, of course, of evolution, I think not very unique, this route of evolution of software architecture. So we started off as a monolith, of course, and it adds several, it has a shared DB, and over the years we spread it around to be, or we evolved to be a distributed monolith, what we call, which is microservices that use the same shared database. And by now we're just really fully pledged to microservices, and we are working on microservices that have its own DB, and each service has its own DB, and of course we use several different database types. It depends really on the business case and the needs for each service, and we're really into event-driven and domain-driven design. And just adding to the context here, so we deploy we do a lot of deployments over the year, and we are very focused about the production sites we use. We have seamless failover between production sites. We're really into availability and cyber and all the other things that are very important to a fintech company. And I put a short list here of things we care about and areas of focus. And I will not be talking about all of them, but I can mention that accuracy and consistency of data, of course, something that is really crucial for a fintech company. Availability and disaster recovery that I mentioned earlier, regulation and security. We're going to mention a few words about regulation challenges and quality processes. This is something very crucial. We must make sure not to do some bugs in production because they can be costly, and I'm talking about really costly. So we took some of the topics from the list that you see here, and me and Sagi, we chose several different areas that we want to tell you about in this presentation, and of course just connecting it all to the start of this presentation. So we're going to talk about how new problems came along during the years, and how we looked at them, and we chose to use some new stuff and new innovation to solve them. Okay, this will be the focus of this lecture, and we're going to start off and talk a bit about refactoring. So refactoring your service without breaking your system, something that, first of all, part of the R&D DNA here is to continuously refactor our code and our services. And why do we do it? We do it because the requirements keep evolving, and the scale requirements and performance requirements keep evolving, and the requirements of the customers, of course, also keeps changing, and we need to adapt really fast to the new, first of all, to the ecosystem of fintech, and it requires us to make a lot of changes to legacy systems, and we're pretty much into it. So let's talk a bit about the problem and the things that we need to consider here. So legacy systems are complex, and I think I'm not the first one to say it, and I'm not getting anything new, but when we talked earlier about taking out a monolith and breaking out to microservices, so it's not always a clean cut, right? Because it's not always order in modules that you can just take and put a microservice. Sometimes there is deep binding between them. And of course, if we talked about a complex system, then no breaking changes is a rule you must remember. You have clients relying on you. It could be they are external clients, and it could be there are internal clients that work within your system, but they rely on you to return or work in a certain way. And just adding to it, I think something that we learned during time that first of all, not always a bug is a real bug in a legacy system, right? Because if a system got used to work in a certain way and the clients that work with it already familiar with it, and it doesn't matter if now we see it and we say, oh, wow, why did it do it like this? Why is it working like this? It doesn't really matter, because whether it's a bug or not, this is the behavior of your system, okay? So bugs become a feature of your system. And if you refactor and you update it to a new system, you must keep the old behavior, right? And of course, adding to it the documentation issues that is familiar for any startup that grow fast. At first we weren't very occupied or weren't very focused about documentation editing, and we were more focused on delivering fast and meeting time to market goals. And nowadays, of course, we must have full documentation for features, and if you don't have it for a legacy system that you want to refactor, it makes things a bit more complex. So adding to that, so let's talk a bit about solution, how we can solve some of the problems that we talked earlier. So of course, we did the previous, when we started refactor, we do investigation of code and reverse engineering, and we collect features and we think about the system and we develop it. And we tested in some environments, and we load tested, but then we want to deploy it in production. And we really want to get assurance that we don't mess things up. And this is why we started with the dry run notion. So what it is, first of all, we have a legacy service and we have a new service that we want to replace. So at first, we deploy it side by side, okay, legacy service and the new service in the silent mode. What does it mean, a silent mode? It means that it doesn't do any commits or changes to real-time production environment, okay? It works side by side. We usually even have some separation here. We use, instead of service A and service B that we're supposed to call in this occasion, then we use a service mock, okay, instead of them. And we deploy it side by side with the legacy service, okay? Now, the next thing you want to do is you want to run some traffic in it. So there are two methods to doing it. First of all, the first method, which is probably the easiest, is to just have some sort of a proxy from your legacy service and have each of the new event that comes around and or event or API call just being populated also to the new service in the silent mode, okay? But the other method, which is actually my preferred method, I will tell you a bit more about it later, is have your client develop the new integration with the new service and just call with the same params the two services twice, okay? It can be events, it could be an API call. It could be that the contract has changed, right? Because this could be an old HTTP or WCF or SOAP client, and now we're working with RESTful clients and we want to populate it to a different contract. But in the end, the same parameters and the same call should be both populated with the legacy service and the new service in the silent mode. Okay, and once you get that, the next thing you want to do, and here comes the tricky part, because until now it was pretty straightforward, you need to compare the results, okay? And here comes the real brain of the operation, okay? We build some sort of an observer, which is a comparable mechanism, which takes the input that comes into the system and takes the output. And the output could be the database fields, it could be what the services got and the mock service got, and it could be the queues, it could be the data sets, it could be anything. But this service works in between and compare the results between production, reproduction, and the dry run, okay? And this comes as a very good observer, and it highlights when we do things wrong and when we mess things up. And what do we get from all this? So first of all, we get much higher confidence when we replace an old service, okay? Because, as I said earlier, production mistakes are costly. They have extensive cost of production mistakes, especially in the fintech industry. okay? And real-time production bug testing, the detection, of course, and the traffic and production load testing, because up until now, until we deployed it, it could be that we did some load testing, but it was in an environment of load testing. It works differently in production. If we do it this way and we move all the traffic also to work with the new service in a silent mode, we actually get real-time production testing of the load that will come to this service, okay? And backwards compatibility, of course, is something that was the trigger for the whole thing. Once you get the comparison mechanism, you can just detect pretty easily when we did things wrong and you change things and it works different than real production, and you can fix them. And just adding to it another notion that if you do it right and you use event source in design pattern and you actually record the messages, and if not familiar with event sourcing, I would recommend reading about it, then you can actually play it again once you fix it, and then make sure that you really fix it and it's now comparing again to production, okay? And adding event sourcing here is something that is very helpful. But the main thing, another great thing that comes along working in the method of doing integration, this is why I actually prefer doing another integration, is you get to test your clients before you really start to run them, okay? Because they run production also in a silent mode, and you get an easier rollout because all the pieces are already in place, and you have now a service, just going back here, so you have now a service that can call this service in a duplicate event, and once you set the flag right, you can just say, okay, now some of the traffic will go here, and some will go to the new client, or either just change it and say, okay, from now on, you're just calling the new service, okay? And if you did the integration and you use feature flags right, then it's very easy to do it, feature toggles. So just to conclude this notion, we also have the backwards compatibility, and let me explain this one for a second. So our legacy services and legacy DB has multiple clients, right? And probably we're not always fully aware of them, but here raises another problem. Okay, so let's say we did run, and all is working great, but we didn't migrate the old clients to the new service, right? But we still want to start rollout in production. So do we have to tie moving the old clients to work with the new service before we start doing it in real production? So the answer is no, we don't want to make this tying up of services. We want to start rollout as soon as possible sometimes, and we want to make sure we do it in a fashion that allows us to both start in production and not be relying on all the clients to move all at once, okay? Also have to mitigate the risk. So we have our new service, okay? And this new service, as I mentioned earlier, we also did some dry run and we moved some clients and now it's working. And in order to make it fully operational, of course, we do some migration of the data from the legacy service and we move data from legacy DB to the new service in order to support the flow, and we can start in production. But wait, now there is an issue, right? Because if we start moving clients to the new service, but we didn't conclude it, so these clients will not get the old data, right? Because this one has the entire data of the service, because if it's get service or whatever, but these guys, no, they don't get the full data because some of the clients already migrated to the new service. So introducing the backwards compatibility, its sole purpose is just populating fields that come or data that come from the new service and populating back to the legacy DB, okay? And why is that important? So as I mentioned earlier, it allows us to be able not to deploy all clients at once. And of course, you have the ability to serve longer some unknown flows and detect them, because if you conclude the rollout and then you still see some reading from the old database, so you know that some clients didn't move and you can detect them this way. It also helps in a complex legacy system. And of course, it completes and it works very good with the dry run notion, because if you have both dry run and backwards compatibility, you control the rollout much easier. And again, just let's conclude this whole notion. This really helps us refactor at ease for a fintech that is complex and for fintech system which is complex, and we do it in much more ease and with better assurance that what we did is right and we didn't break anything or mess things up. Okay, so now I'm passing on the mic to Sagi to share some insights about regulation requirements and tell you a bit about it.
Thanks, Eran. I'm Sagi. I'm the Financial Infra Team Leader in Payoneer. And today I want to speak with you about part of our regulation flow called entity screening. Let's start with a little background. So in Payoneer, we transfer a lot of money around the globe, and we want to make sure that this money doesn't get into the wrong hands. For example, terrorists, organized crime members, politically exposed people. There are many sanction lists defined in different sources by different organizations like the UN and the US government, and we, in order to be regulated to transfer money all over these places, we need to make sure that we're screening against them and not allowing money to transfer to those sanctioned entities. So we need to create some sort of a tool that will help us to separate between the cleared entities and the suspicious ones. We need to screen each entity, each Payoneer user and each transaction made by that user, both the source of the transaction and the destination of this transaction. For example, if I'm a Payoneer user and I want to make a payment outside of Payoneer, I need to screen both my data and the destination of funds data. For example, I'm paying for a supplier. I need to check his name, his address, his date of birth to make sure that he is not a sanctioned entity. This might get a little tricky, as each name can be written in different variations, and also date of birth can be written in different formats around the globe. And we want to make sure we're screening all of them, because in the sanction list, the names won't appear as all the variations, but one. And we need to make sure that we're comparing all the names that we're resulting in good results, comparing each variation of the name to the original name. For example, we'll take this Chinese businessman called Sander Peng, and you can see here that both his first name and last name can be written in different variations. Which lead us to think how we will design this system. So first and foremost, what the database we're going to work with. We chose to run noSQL, and this because of many reasons. But first of all, we're reading and writing a lot of complex data, a lot of complex entities, and it's very time-consuming doing it over a rational database. And we don't want to store our entities in 4 different tables. We want to store all the each entity with all the relevant data for it in one table, document, whatever. So it will be easy to access. And so, which led us to the definition that we need low latency and flexible schema storage. Also, we're performing trillions of entity comparisons, which is not the best usage of our resources to run them on the CPU. It will take too much time, and it might make our customers wait longer for their financial transactions to be completed. So, long story short, we need to have a low latency, schemaless, and a support for MapReduce and aggregation over the database, which led us to using MongoDB. MongoDB, as you all know, is a document DB, which means it's schemaless and it has support for indexes. It has fast aggregation framework, and also it's really fast to adapt to. There are a lot of good documentation over the internet and online courses, which are really good. Also, Mongo University, and it has reduced I/O when using embedded documents, which is all great for us, and we will be able to store all our relevant entity data in one collection. For each entity will have all its names, addresses, and dates in one document, and it will be much easier to work like this. Speeding it up, we have 4 levels of comparisons, which the highest is the least filtering, and it has the highest matching, but it is the fastest. And as we're going down the comparison pyramid, it has more slower, but more accurate, more filtering comparison. But I will focus only on the first stage. This is the one that is done over the database, over Mongo. This is part of our code, which presents how we're using our the vast abilities of Mongo. We have here is the usage of our finding the pairs between the entities, pair of names that are matching between the internal entity and the relevant sanction lists. So what we're doing here, we're trying to find everything that matches our internal entity, and then we'll project and group all the relevant names matching it, and we'll use the unwind here twice in order to find all the matches in a single document, not as an array of matches. And we'll group them again and count the number of matchings in order to make sure we have enough names compared in order to move forward with our detailed comparison. And I want to share with you some statistics. As you can see, most of our requests take lower than 1 second, and most of the time is actually being spent on the CPU for creating the matches and publishing them. But when we try to run the same usage over a rational database, even the simplest comparison without creating matches, without creating nothing, took us over a couple of minutes. And we use the best DBAs on our team to improve it as much as possible, but it didn't go any lower than 1 minute. Some name comparison example, how things work. We remark our threshold for an alert at 82%. So on the left column, you can see the first name, for example, the username, and on the second column, you can find the sanctioned entity name. So if we're comparing Ali Saeed versus Saeed Ali Akbar Tabata Bai, we'll get an 85% comparison, because we're comparing the Ali versus the Ali and the Saeed versus the Saeed, which will result us with this score. We're discarding the rest of the names because we have no match, because there are not enough names on the left column. While we're comparing Muhammad Asad versus Muhammad Awad, which looks very similar because there is only one letter that differentiates between the two, we will get a score of 77. Even though it's only one letter, because it doesn't sound the same, and probably this is not the same person. The third case I find the most amusing, as we're comparing here Zai Peng versus East Sea Shipping Company, and it results us with a 92%, which looks odd at first look. But what happens here is that we're comparing Zai Peng versus shipping, which pretty much sounds the same. And the very long names comparison, I'm not going to read it, but you can see that if you are discarding spaces, adding dashes, playing a little with the names, you can get pretty similar names, and we will receive here a score of 93%. This flow has to be available at any given point in time, because once we cannot screen our entities, we cannot transfer funds to them, we cannot process their payments, which is basically Payoneer core business. So let's see how we're doing it. We have two availability zones, one in Israel and one in New Jersey. And for my example, Israel will be considered as the active site, and New Jersey will be the non-active site. And for each replica set, we have three instances per availability zone. And on the active one, there will be one defined as primary, while the two others will be defined as secondaries, which means they all can receive traffic, they're all available to vote, and they are all replicating data between them. While on the non-active site, in this case, New Jersey, we will have all the instances defined as secondary hidden, and will only replicate data. They won't receive any traffic at all. And on a click of a button, we can toggle between the two, making New Jersey as the active site, redirecting all the traffic to it. One of the instances there will become primary, while the two others will become secondaries. And all the former actives will become a secondary hidden, which will mean from now on they will only replicate the data and stop receive any traffic. Back to you, Ran.
Okay, thanks, Sagi. So let's talk a bit about data consistency. So for that, I want to present to you some business case. Let's talk about activity. So what is it? So activity is an holistic view of your entire balance, right? And because we're a financial system and you can do several actions, and you want the customer to be able to get into his account in Payoneer and see all the transactions he did in different areas of the system and get it all in a holistic view. So, and the data, of course, derives from the different actions he did. And so what's the challenge here? So as I mentioned earlier, we are in microservices, and each service has its own database, and actions are performed within each service. And of course, we have some common layer, but again, some of data still derives from the service itself. And you want to have ability to show and get the entire data in a holistic view, which requires us to move some data and share data and keep it consistent and accurate across the entire system. So this is the problem. And let's talk a bit about solutions. So the first one was, and this is still working in production, is an ETL and an API call. So how does it work? So we marked some common fields that are relevant to all activities. Let me extend this for a second. If we see two different activities, one is withdrawing to your bank account, and the other one is getting paid by one of your partners, for example, getting paid from Upwork, then each of them has the common fields that are common or generic per payment or per transaction, and some of them are unique, because withdrawal to bank shows the bank account and characteristics of the bank withdrawal, and payout from a partner shows where the money came from and some information, of course. So what we did is separated. We took the common fields, which are generic, and we put an ETL between them. ETL, if you're not familiar with the term, is extract, transform, and load, meaning you extract from the one data source, you transform to the language that the activity database knows, and you load them. And this keeps happening all the time. It's event-driven and event-based, and it's happened all the time with all changes. And again, there is some fields that are not generic, and how do you get them? So we added an API call for the additional data. We call it enrichment or get details, and this allows you to get the additional data from the actual service when you want it, okay? And this solution also adds some ability to search, of course, and you mainly search around the shared schema. It's more difficult to get the data from the API calls and search on them because it arrives per demand. And at the end, we add some structured type schema for the activity, at least for the common fields. So let's sum things up for now. We have a solution that works. We did create some strongly coupled between data sources, as I showed earlier. And it is sensitive for small errors because ETL are sensitive, right? If you change the structure of one database, and so you need to make sure always to update the ETLs for it. And it has another problem, which is inability to serve all the business needs, okay? So why is that? Because in the end, you rely on the shared DB, and the whole notion of getting the extended details per demand is pretty problematic. And adding to that, shared details might change over time, so you can't just pre-populate it, then you are not consistent anymore or accurate. So we're talking about the next generation, and let's talk a bit about the requirements first. So first of all, it must also work. It should be loosely coupled, it should be robust. It should support some advanced reporting, aggregation, and complex queries to support the business needs. Okay, so this one is still at work, but I would like to share it with you for a second. So in the end, we're going to rely on MongoDB to serve us the additional requirements that the business needs, and it serves just right for the queries and the aggregation we need here. And in the end, we're creating some system that is able to ingest data from different sources. It can be API calls in this example, or it can be using events or whatever method you want to populate the data from. And of course, there is an all queuing mechanism to make it work and robust, and the balancer that helps us calculate and see that we all get all the activities and get the right balance to this account. And of course, the readers that will be able to get the data from the MongoDB database and share it for the different business case. Okay. So just to sum things up, this is still at work, but I would be glad to tell you more about it once it goes live and in production and tell you how it works. So concluding, I must get Uri is credit here. So this great picture comes from the Uri Levin website, and fall in love with the problem, not just solution. And again, complex domain can give you a creative ground for problem solving, a ground for creative problem solving. And solution toolsets, always update it. Don't reuse the same solutions just because you know them. And of course, just put it in the Mongo. It may solve most of your problems sometimes. So thanks a lot. I hope you liked it. Please feel free to stand by and ask some questions. And if you want, you can also use the emails right in here to write additional questions. If you really liked it, you want to join us, check out our career page. Thanks a lot, guys.